How's it going? Let's get something straight here. No one watches these videos for fun. Except you, of course, Miss Bennett, but no judgment here. In fact, we make these videos partly for the grade, but also partly to help our peers understand the parts of physics that were assigned to us. Emphasis on assigned. With that being said, let's get right into the Doppler effect. Meow. The Doppler effect was named after Christian Doppler, who first came up with the idea in 1842. He learned that sound waves would have a higher frequency if the source was moving toward the observer and a lower frequency if the source was moving away from the observer. The Doppler effect is an apparent change in wavelength for light and frequency for sound observed by a person. The Doppler effect can apply to any type of wave, but is mostly characterized and associated with both light and sound waves. There's no actual change in the frequency or wavelength, but it just appears to be so for the observer. For sound, as an object goes toward the observer, the sound of the object will appear to grow louder and louder. Think of like an ambulance when it has its siren blaring moving towards you. While as soon as it passes you and is traveling away from you, the sound will appear to become quieter. For a light, any object that is moving away from us in the solar system, for example, is where we see it the most. It will be red shifted because the wavelength appears to be longer. When it is moving towards us, the wavelength will appear to be shorter and it will blue shift the object. Think the Andromeda galaxy, because since it is moving towards us, it appears to be blue. We can solve for the observed frequency of an object when it comes to the Doppler effect of sound by using velocity of sound divided by the velocity of sound plus or minus the velocity of the source, all times the frequency of the source, to equal the frequency observed by the person. One way to visualize the Doppler effect is to think of sound waves as pulses emitted at regular intervals. Imagine that each time you take a step, you would emit a pulse. Each pulse in front of you would be a step closer than if you were standing still, and each pulse behind you would be a step further apart. In other words, the frequency of the pulses in front of you is higher than normal, and the frequency of the pulses behind you is lower than normal. One way that the Doppler effect of light was used in history is that Edwin Hubble used the Doppler effect to determine that the universe is expanding. He did this because he found that light from distant galaxies was shifted toward lower frequencies, red shifting the galaxies on the spectrum. If the galaxy was moving towards Hubble, then the light would have been blue shifted, which would have determined that the universe was, instead of expanding, contracting. Doppler radars are also used to help meteorologists learn about possible tornadoes and other natural disasters. So the Doppler effect can also be used in medical science as well. There's something known as the Doppler echocardiogram, and it is used to send sound waves down into the heart, and the sound waves that bounce off the blood cells moving through the heart and blood vessels can help determine the speed and direction of blood flow in the heart, which is very helpful to cardiologists when they are studying and determining if someone has a heart disease.